Right. Now we are going into dimensional analysis. Dimensional analysis. Dimensional analysis. The first thing I want you to understand under dimensional analysis is something we call dimensional homogeneity. Dimensional homogeneity. Is it law? And what does it say? It says that when you have an equation, the correctness of that equation can be tested by looking at the dimensions at both sides of the equation. An equation always has a right hand side that's equal to a left hand side. So every equation is expressed as left hand side equals to a right hand side parameter. And for that equation to be correct, maybe you have a formula in physics. For that equation to be correct, you can test this using law of dimensional homogeneity. I need to clarify something, a disclaimer. Dimensional analysis cannot completely decide if an equation is correct or not. No. It can only suggest if an equation is correct or wrong dimensionally. So you are looking at the dimensions alone to determine if it is correct or not. But now, if an equation is dimensionally incorrect, it means that that equation is incorrect. But an equation can be dimensionally correct, and yet that equation in itself is not appropriate or completely valid to be used as an equation. Why? Because so many things surround equation. Example of such a thing are constant and coefficients that you cannot ascertain from dimensional analysis. You see that now? The numerical values of those constants is what I'm talking about. Alright, very good. Now what is law of dimensional homogeneity? It says that the DIN, that is the dimension of the left hand side, must be equal to the dimension of the right hand side. So you are given equations, you want to test that equation, you need to look at the dimension at the left and the dimension at the what? At the right. Okay, let's quickly check this thing out. So imagine for example, let's say an equation we know and test it. We know the equation that says E is equals to MC squared. Yes. Let's quickly test this equation is the formula of relativity. Let's quickly check if this equation is dimensionally correct. What are we going to do? We'll check the dimension at the left and check the dimension at the right. What dimension at the left? E is energy, we know that. And what that is the dimension of energy? Energy is what? mL squared T minus 2. If you check your notes, what we just did now, energy is this. Equals to, solve mathematically normal. This is mass, M, times what? C here stands for velocity. They will give it to you. They will tell you what each thing stands for in the question. C is velocity. So here, we now have what? Velocity dimension is what? LT raised power minus 1. And that C, the raised to the what? Power of 2. We put the 2 outside. That's this, the whole of C raised power of 2. So let's check. ML squared T minus 2 is equal to what? M times L, when you want to put this is L squared, T times minus 1 is minus 2. That's sorry, minus 1 times 2 minus 2. And what do you have? ML squared T minus 2 is equal to ML squared T minus 2. So you can see now that this is the left hand side. You can see now that here we have the left hand side of the equation. Left hand side, and here we have the what? The right hand side dimension. Are they equal? Yes. Since they are equal, you will now write that the equation this is what? Is dimensionally correct. Please don't go and write the equation is correct. The equation is dimensionally correct. Why? Because they could give you 4 and put 4 in this place here. 4 equals to MC squared. If you calculate the dimension now, the constants do not affect dimension. So even if the equation came as equal to 4MC squared, you don't need to put the 4. 4 is dimensionless. You work with only the parameters there, and you still get the same thing. Does not mean that the formula is correct because the formula does not have the 4. So you see what I'm saying? You must specify that it is dimensionally correct. Alright, good. We are going to use this idea now and solve some questions. We have some questions displayed here. We have some questions displayed here now. Alright, good. So let's look at these questions and then we'll be solving with them. Alright, here. I can wipe up this. I Can I put this? Alright, the numbers. Yeah, now the first question said, but this first question is about us deciding the equation is dimensionally correct or not. Alright, so let's look at how they structured the equation. They gave us an equation, S equals to UT. So solution to problem 1, solution to problem 1. They gave us an expression where they said what? S is equals to what? UT plus 1 over T AT squared plus lambda T. It kind of looks familiar, right? Okay, sorry. Plus lambda U squared. Thank you. Plus lambda U squared. They said here S is displacement. Now that they said S is displacement, it means that we know that S, the dimension is L. They said U is initial speed. That means U dimension is what? Speed. That is LT minus 1. Check the table we just used. That is the direction. A is acceleration. That means we know that one is LT minus 2. And T is time. That's capital letter T. What must be the dimension of N? What must be the dimension of N for the equations to be valid? So for us to know the dimension of lambda, the dimension of lambda for this equation to be valid, we have to appreciate the statement valid. So if they are trying to tell us that the equation is valid for a particular given dimension of lambda, it means that we're saying that given that lambda, are you getting now, has a dimension that validates the expression above, then we can easily tell ourselves that dimension of left hand side should be equal to the dimension of right hand side. And quickly, what do we do? Let's start representing everything in dimension, and we'll be making this subject of formula to know the dimension. It should be for this to be valid. What dimension of S is M? Because it says displacement. I said it's equal to U is what? LT minus 1. It's very simple. Just follow what you're seeing here. And T is T. So we have times T. Then we now have plus. Let's sectionalize so that we will not be confused. Plus 1 all over 2. I told you we don't work with constants. We don't work with constants. Plus what do we have there? A is what? A is simply acceleration, which is LT minus 2 multiplied by T squared. Plus, we don't know what lambda is, but we know that this one is LT minus 1, everything raised to the power of 2. You can see that the U is this one, everything raised to the power of 2. Alright, if you look at it carefully, L is equals to minus 1 plus 1 is 0, and T raised to the power of 0 is 1, so we're left with L here, plus minus 2 plus 2, you know these are TT, minus 2 plus 2 is 0, but let's go to L again. Plus, when I open that up, lambda L squared T minus 2. So notice that the dimensions of this is equal to the dimension of this one, equal to the dimension, but this is what we want to work with. So we already know that the dimension of this side is L. So that tells us automatically that this dimension here, everything here should also give me a dimension that is equal to L, that is equal to the left hand side point. So I'll come here and say that therefore it's imperative that we know that what? That lambda L 2 T minus 2 should be equal to L, because we've seen that the left hand side and the other side the dimension is L. So whatever this place is should be L, just the way this place is L and here is L, here should also be L. So we want to know what should lambda be to make this place L. Let's fly. So from here now, we make lambda the subject of formula. Lambda will now be equal to what? L all over, we are divided by these things here, L squared T minus 2. So what is lambda? Lambda can be equal to what? L1, L only 1L, I'm left with 1 over L T minus 2. If I bring this guy up here, lambda has to be L raised to the power of what? Minus 1, we bring L up, and T is just minus 2, we come up with just the T raised to the power of 2. That must be the dimension of lambda to make this expression dimensionally correct. And that is how to solve that problem. Let's go for problem solution to problem number 2. I'll be leaving problem number 3 for you to solve and drop your solution for us on the comment section, and once you can get to 200 responses, I will drop the solution myself on that problem 3. So let's quickly look at the problem 2. The problem 2 is in the very similitude structure of problem 3. So if you understand what I'm going to do in problem 2 now, you won't have a problem solving problem number 3. Now they said, in this case here, you have different things you want to check the relationship. So you have to work with a certain principle to get the relationship of how one parameter depends on other parameters. Now they said, assume the period t of a simple pendulum depends only on, now once they tell you that, they are telling you that t is depending on something. That means there are certain things that when those things change, it affects the value of t. That means they are saying that t varies in a particular way with, that depends only on its length. So we say its length, it depends on gravitational field G, and it also depends possibly on the bulb mass N. You soon know why they wrote possibly on the bulb mass N. So dimensional analysis can help you structure out a formula that can work. I get it now, given that you know the constant that surrounds it when you are giving questions like this. Alright, so T, we have this now, so they are related, it relates with this and this in a given way. The fact that we don't know how they vary, if it's direct or indirect or to the power of, we have to just put their variation order here, X, Y, and Z. So you can see that even without them giving you this expression like this, you can formulate your own expression. It's the same thing. The only thing here is that they work with Greek alphabet. Let's follow what they used. Alpha, but if they didn't give it to you, you can structure out yours and work with it. Alpha, beta, and gamma. We know that whenever you have expressions like this, you can open it and become K, where K is the dimensionless constant. L alpha, G beta, and N lambda. So our have to state here, K is dimensionless. And when we say something is dimensionless, that means it has unity dimension of 1. Not have any dimension. Alright. So very good. How do we now work with this? Very simple. Spread out every single thing you see here based on dimension. Remembering K is just a constant. So leave K alone. Just work with the parameters you have. So this T here stands for period. Period is time. Don't be confused. The dimension of period is the same thing as time, T. So I have my dimension here, T. So the only thing there is T. I'm going to write M0, L0, and T. Raised power 1. You know, when you write on it, it's the same thing as T1. Why am I just doing this? I'm just trying to do this for clarification purpose. It means that the dimension of T does not have M, does not have L. So it's still the same thing. M0, L0, 1 is just T. But I wrote it here for comparison's sake. You see now. What do we have here? L, length, I mean. You can see there, length. So I'll just come here and write length raised power of alpha, because we have to look for alpha, beta, and gamma. G is acceleration due to gravity. Whether your acceleration due to non-entity, acceleration due to poverty, acceleration due to anything, you are still acceleration. Your dimension is the same. So for that G now, I have LT raised power of -2. I know now that's gravity, acceleration. But you know it's raised power of beta here, so I'll put the beta here. Then you have M, which is called mass. So I have mass, direction of mass is still M, raised power of this. So let's open up everything here and solve it. So I'm still having my M0, L0 at the left hand side. This place here, L alpha. When you open this, you have L beta, T -2 beta. And I have M lambda. So let's arrange this accordingly to be M, L, and T. So I have M0, L0, T1 equals to, what's the first one here? M. Is there any other M? No. So I can write my M lambda. Then what's the next I want to write? L, I mean. L. So we have L. How many L's do I have? I have L alpha and L beta. So L alpha times L beta gives you L alpha plus beta. Then I have T. Is there any other T? No. Only T raised to power -2 beta. Now this is where you see why I said. You know we said for dimensional homogeneity, for an equation to be correct, they have to be express dimensional homogeneity. Dimension at the left should be the same as the right. So that means whatever m raised by 0 is here is what should be m in this place. Whatever n is here should be what n should be here. Whatever t is here should be what t should be here. Do you get the concept here now? That can help us know what all these orders, all these exponents are. It can help us know what they are. It can help us decode them. So yeah, what do we have now? So from there now we can say for m, let's start with for m. For m, we can see compare the order. M here is lambda, m here is 0. So for m, we can say lambda is equals to 0. We've gotten that one. Very easy. So how about for n? Let's see for n. What do you have for n? L here is 0, I mean, raised power of 0, but here is raised power of alpha plus beta. That means alpha plus beta should be equal to that 0 for n. That's what we're saying, comparing them. So we are saying, it's just like saying L0 was equal to L alpha plus beta. What do you do? L cancel L. So we are saying that alpha plus beta was equals to 0. Let's just keep this equation. Just keep it, an equation. Then let's go for t. Because if you have two unknowns, you can't get them as one. So let's go for t and see if miracle happens. For t here now, we are having t raised to power of what now? 1 at this side. We are having t raised to power of 1. And we are saying that it's equal to t raised to power of what? Minus 2 beta. Minus 2 beta. T can cancel t. And then you have minus 2 beta is equal to 1. Can we get beta? Yes, divide both sides by minus 2. By minus 2. Cancel. Beta now is equal to minus 1 over 2. Now that I've gotten beta, we can now use beta value in this equation here to get alpha. Alpha plus beta was equals to 0. Now we know that beta is minus 1 over 2. Alpha plus open bracket minus 1 over 2 is equal to 0. So beta is minus 1 over 2. Plus and minus is minus. Alpha minus 1 over 2 is equal to 0. So that alpha can be equal to, when you carry this on to the other side there, it turns to 1 over 2. So we know what alpha is. So therefore, we can now conclude and state that what? That our alpha by solving was equal to what? Our alpha was equal to 1 over 2. Our beta was equal to minus 1 over 2. And our gamma was equal to what? Our lambda was equal to 0. Now, let's come now. When you have done something like that, you come to this place here and impute all those values inside to get the expression they're asking you for. Because the question was asking you for the relationship, that the expression. So what do we now have from here now? I can easily just tell myself now that is t is equal to a constant k. Are you there now? L. We have L raised to the power of alpha. What do we get as our alpha? 1 over 2. Then you now have what again? G. G is raised to the power of b now, right? So we have G, which is raised to the power of beta. What's our beta here? Minus 1 over 2. Multiplied by again n raised to the power of gamma, and gamma is what? 0. Anything raised to the power of 0 is 1. T is equal to what? KL 1 over 2 dot 0 to the power of 1 over 2. M has disappeared because M is power of 0 is 1. That's why they tell you that the mass of the pendulum bulb is independent. Sorry, the period of oscillation of the pendulum bulb is independent of the mass. So that's what happens here. They are talking about the period of oscillation of pendulum bulb, and you can see now that mass has disappeared from the expression. It means it does not depend on mass. You see how dimensional analysis reviews some key things about the particular occurrence in physics. Very, very key. Now here we have what? We can solve for that. We can solve for that to get an expression. See now, and because remember, whenever you have a raised power of 1 over n, is simply the nth root of a. Remember, so we want to apply that here. So that's k. What do we have here? We have k, n raised to power of 1 over 2. This g can go down since they have minus, g raised to power of 1 over 2. You see, it's got to be minus. Remember that thing that I explained earlier. So since this one down has 1 over 2 and this one here has 1 over 2, you can express them in their root form. So that's like say t is equal to k dot root l, that's square root of l. You know, when you have a raised to power of 1 over 2 is now square root of a. You don't need to write the 2 there. This is still the same as square root of a. Any other root you must show it. So since it's square root, you don't need to do the 2 there. So we have this all over the one for g. All over the one for g. Now, when you have a raised root over b root, since it's the same root, you can just say it's equal to common root a over b. And we can apply that here also. So here, t is equal to k common root n over g. So that's the expression there. So from the expression, we can see that t is equal to k square root n over g. So that's it for that. That's it for that. Now from this now you can now see that the dimension analysis has been able to give us an expression that likens to the formula. So if you are a student and you studied actually and maybe you forgot the expression of how period connects with length and gravity, and maybe they give you a equation, there's length, the equation, there's gravity, there's period, you can quickly do dimension analysis to get an expression. When you get this, if you have the calculator that studied, you will remember what probably the constant k is there. In this case, the k there is 1 over 2 pi. Understand? If it's frequency, you have in 2 pi. So, and then this will invert. But fine. This is what dimensional analysis protocol looks like. So here we have the question. Here we have the question for you, and then you can go ahead and attempt the question. You can go ahead and attempt the question. When you get the answer, just drop it in the comment section, and if you want me to drop the solution, just request for it in the comment section. Once I can see 200 requests, I will do a video to solve this question, and I will also solve 10 more questions on dimensional analysis. So do well to make sure you click on the notification bell so that when I drop the next video, you will be notified. I remain my humble self, Henry's Impact International Academy.